Yes, good morning students. Yes, write down the problem on the conduction, convection and radiation. Yes, write down the first problem please. Two walls having thickness are in the ratio of 3:2. Full stop. Calculate if ratio of their thermal conductivities is 1:2. Then calculate temperature of their interface. The temperature of outside walls are 40 degrees Celsius and 50 degrees Celsius. Right? देखो इसमें क्या हो रहा है? Basically there are two walls. Which is having the thickness in the ratio of this. मतलब this is T1 thickness. This is T2. And thickness are in the ratio of, that is 3:2. मतलब T1 by T2, it is 3/2. Calculate the temperature of this, and this having the conductivity is K1 and K2. This K1 by K2 is 1/2. If the temperature of outside ones, let's suppose its temperature is 40 degrees Celsius and this temperature is T2, 50 degrees Celsius. Then calculate the temperature of interface. Calculate the temperature of it. हमको उसका टेम्परेचर निकालना है. We have to calculate that temperature. देखो मैं उसके लिए कैसे डील कर सकता हूँ. We know the conduction will occur, and if the conduction will occur, these two are connected in series. मतलब जितना हमारा हीट करंट इधर से फ्लो करेगा उतना ही हीट करंट इधर जाएगा, चाहे यहाँ पे I1 हो या I2 इधर I1 हो सकता हूं मैं I2 I1. तो मैं क्या कमेंट कर सकता हूं, इधर से इधर जाएगा कितना, पहले टेम्परेचर डिफरेंस 50 - T अपॉन V by R. What is the resistance? 1/K2 into T2 by A. And this is T minus 40 1 upon K1 into T1 by A. Right? Now, if we will solve it, this A and A will cancel out. Yes, this is 50 minus T by T minus 40. It is, ये उधर जाएगा, that is T2 by T1 into ये K2 और इधर K1 by K2. K1 इधर K2, it is K1 by K2. Right? So what is T2 by T1? Look at this. T2 by T1. 3:2 is what? Well, in the question we have given T1 by T2 is 3/2. We have also already written that T2 by T1 is 2 by 3. And what is K1 by K2? 1 by 2. That is 1 by 3. Now, अगर मैं इसको solve करूं, this is 50 minus T. That is 150 minus 3T is equal to T minus 40. That is 40 is equal to 190. T is equal to 190 by 4. (47.5 degrees Celsius). Right. So this is the value of the interface temperature, that is 47.5 degree Celsius. Is it clear? Yes, right. Yes, next. Next is a cylinder having inner radius R1 and outer radius R2. Calculate thermal resistance offered by it across its axis and outer body. And outer surface. Axis और उसके about बताओ. If thermal conductivity of it is varying as K is equal to K1x plus K2, where x is equal to distance from its axis. Means this is a cylinder and its inner surface is this. The axis of cylinder is this. Right? And material is filled in it. This is the distance x. We have to calculate what? We have to calculate the thermal resistance offered by it across its this and this. Right? But the point is that its thermal conductivity is not constant. It is changing. Second thing, when we are moving outside, then the area through which it is flowing. जैसे मान लो मैं ये लेता हूं, एक सिर्फ ये द एरिया थ्रू विच इट इज फ्लोइंग, वो एरिया हमारा यहाँ पर कांस्टेंट नहीं है, दैट इज चेंजिंग. तो मुझे क्या करना चाहिए? एक्स में जाके एक dx कट करना चाहिए. तो व्हाट इज d स्मॉल r? रेजिस्टेंस. दैट इज 1 by k एट दैट टाइम. एक्स पे जाके कट करा. लेंथ इज dx. व्हाट इज द एरिया अक्रॉस विच इट इज फ्लोइंग? बाउंड ऐसे फ्लो कर रहा है. दैट इज 2 pi x dx. वो इसमें से फ्लो कर रहा होगा. तो इसकी लेंथ मान लो L है, सिलेंडर की लेंथ. इट इज 2 pi x into L. इस एरिया में से फ्लो कर रहा होगा ना, क्रॉस सेक्शनल एरिया इसमें से निकल रहा होगा, लैटरल एरिया. नाउ व्हाट इज K? इट इज K1x plus K2. तो अगर मैं इसको सॉल्व करूं तो व्हाट इज dr? दैट इज dx अपॉन that will become 2 pi into k1 into x square plus 2 pi into 2 pi तो कॉमन है, कांस्टेंट है, इसको बाहर रखो. 1 upon 2 pi तो बाहर रखो, L. It is dx upon k1x plus k2 into x. That is 1 upon 2 pi L dx upon k1 x square plus k2 x. Integrate it. When you will integrate it, you are able to calculate that is the value of resistance offered, and integrate the x from R1 to R2. From R1 to R2. So integrate it to calculate the value this. It is dx by k1 x square plus k2 into x. Right? So we need to integrate it to calculate the value of resistance. Right? So इस टाइप के फंक्शंस को हम इस प्रकार से सॉल्व कर सकते हैं. Next. Yes, next. Write down the next question. Calculate the ratio of heat current offered by by conductor. Calculate ratio of heat current offered by conductor as shown in figure. If area of cross section comma thermal conductivity are same. So we have given the conductor like this. These are the two conductors. Its temperature is T1. Here the temperature is T2. Let's suppose this is L. It is given. So we have to calculate the ratio of heat current. मान लो कि हमारे यहाँ पे करंट चलता है I1 और यहाँ पे करंट चलता है I2. तो व्हाट इज I1 by I2? I1 by I2 is equal to delta T by R1 by resistance delta T by R2. Delta T and delta T will cancel out. So it is R2 by R1. Now resistance is proportional to length. Resistance is proportional to length. The resistance of this is L. So what is R2? It is जितनी उसकी length है. Now what is the length of this? If it is L, L is 2R, just radius. And इसकी लेंथ कितनी होगी? L1. That is pi r. What is r? L by 2. So this is pi L by 2. So it is L2 by L1. This is pi L by 2 by L. This is pi by 2. Right? So that is the value of the ratio of heat current offered by these two conductors. Next is 3 rods made up of copper, aluminium, copper and steel have equal lengths and their thermal conductivities are 200 unit is SI unit. What is SI unit for this? That is thermal conductivity. Conductivity is 1 upon K. 200, 400 and 50 respectively. In SI unit. Full stop. Calculate temperature of the air of their intersection point if endpoints temperature are 20 degrees Celsius and 50 degrees Celsius as shown. Equal lengths and cross sectional area. So this is given. There are 3 rods given like this, which are made up of equal length. This is made up of aluminium. This is of copper. This is of steel. Their temperature is 20 degrees Celsius, 40 degrees Celsius and 50 degrees Celsius. And their K is given 200, 400, that is 50. Right? We have to calculate the temperature of it. Right? तो देखो हम क्या लिख सकते हैं. मान लो इधर से I करंट चलता है, यहाँ जाता है I1, यहाँ जाता है I2. So we can write I is I1 plus I2. Here I is equal to I1 plus I2. Now what is I? I is delta T by, that is 50 minus T by resistance. What is the resistance of this? 1 upon 50 into L by. What is I1? I1 is T minus 40 by 1 upon 400 into L by. What is I2? T minus 20 by 12 by. This L by and L by cancel out. So what is the remaining thing? This 50 ऊपर जाएगा, इसको कटिंग करेंगे तो ये क्या बचेगा? 8 और 50 minus T is equal to what? 80 4 times t minus 20. This is 8t minus 320 plus 4t minus 80. 13t minus 400 is equal to what? 12t minus 400 is equal to 50 minus t. So 13t is equal to what? 450. So what is t? 450 by 13. That is the point. 450 by 13 degree Celsius. Right? So it is 450 by 13 degree Celsius. Is it clear? So this is the point. Next. राइट तो इस प्रकार के क्वेश्चन को हम इस तरीके से डील करते हैं और इस तरीके से सॉल्व करते हैं. यस, राइट ऑन द नेक्स्ट क्वेश्चन. अ बॉडी cools from 60 degrees Celsius to 55 degrees Celsius in 10 minutes. Using Newton's law of cooling. Using Newton's law of cooling, calculate time taken by body to cool from 55 degrees Celsius to 50 degrees Celsius if temperature of surrounding is 40 degrees Celsius. Temperature of surrounding is 40 degree Celsius, right? तो इसमें क्या हो रहा है, एक बॉडी जो है वो कूल होती है फ्रॉम 60 टू 55 इन 10 मिनट्स. देखो इस चीज को हम यूज कर सकते हैं. वैसे न्यूटन लॉ ऑफ कूलिंग में वी हैव डिराइव्ड द रिलेशन ऑफ व्हाट, वी हैव डिराइव्ड द रिलेशन ऑफ द इंटीग्रेशन, कि उसका इंटीग्रेशन से कैसे टेम्परेचर फॉल हो रहा है. लेकिन उसको करने का एक तरीका और भी है, दैट इज एवरेज मेथड. सो आई एम यूजिंग द एवरेज मेथड. एवरेज मेथड में देखो हम क्या करते हैं. वैसे हमें पता है कि रेट ऑफ कूलिंग इज दैट डिफरेंस इन टेम्परेचर. तो दैट इज रेट ऑफ कूलिंग. रेट ऑफ कूलिंग मतलब चेंज इन टेम्परेचर, दैट इज T2 माइनस T1 का नेगेटिव चेंज इन टेम्परेचर बाय टाइम टेकन is K times एवरेज. T माइनस T नॉट होता है, बट T को हम लिखते हैं T1 प्लस T2 बाई 2. minus T naught. We will mention like this. T1 plus T2 by 2 minus T naught. राइट जैसे यहाँ पे T1 कितना है T1 इज इक्वल टू 60 जैसे फर्स्ट केस में यूज करो ये T बन गया मतलब हमारा हेयर फर्स्ट केस में अगर यूज करेंगे T1 टू T2 60 टू 55 तो इट इज -5 आएगा बट माइनस लगा तो 5 by delta T. What is delta T? 10 minutes. K times T1 plus T2 by 2. 60 plus 55. 115 by 2. 57.5 degrees Celsius minus T naught. What is T naught? 40. Five degrees Celsius by 10 minutes is equal to what? 57.5 minus 40. That is how much? 17.5 degrees Celsius into K. Right. So this is the first equation. Now what is the second equation there? What is the second equation? Second equation is again it is falling from 55 to 50. If it is 55 to 50, then it is 50 minus 55. Minus 5 by delta T. K times 55 plus 50. 105, that is 52.5. Minus 40. 5 by delta D 12.5 रेशो लेंगे तो क्या बनेगा डेल्टा T by 10 और वो चीज को अगर मैं यहां रखूंगा क्या बनेगा उसको इधर 12.5 25 से अगर मैं कटिंग करूंगा तो इट विल बिकम 7 by 5. तो व्हाट इज डेल्टा डी 7 by 5 into 10 minutes. It will take 14 minutes. It will take 14 minutes there. Clear? Yes. This is the value. Write down it, please.